Welcome everybody. Let's talk about demystifying options. And today we're going to talk about the Greeks. A lot of people don't understand the Greeks and they don't know what they mean, and it's all very confusing for a lot of people, so they don't trade options because they're scared of it. But today we're going to demystify the Greeks. This is going to be a very comprehensive video. It shouldn't take that long, okay? Maybe 10-15 minutes, so just hang in there. So let's talk about the Greeks. What are they? Here we got a stock called BRY. It's the Berry Corporation. We're just using this as an example today. And here we are looking at options chain. Okay, here are the strike prices down the middle. And we're going to focus particularly on the $7.50 strike price on the call side. So it's going to be this line right here. So what are the Greeks? Greeks are delta, the gamma, the theta, and the vega. Now there's others, but we're just gonna focus on these four, okay? So we can see at the strike price, these contracts are for April 2023 for this symbol. And over here, who I didn't mention, and I'll mention it now, this column right here is implied volatility. This is all kind of squished together, so it's hard to see. But I'm going to switch over to a spreadsheet real quick, and we're going to go through, and I'm going to show you how to use how to use the Greeks. Okay, and the spreadsheet's actually going to show us and calculate the changes as each of these change, and we can get a really good understanding of the importance of understanding the Greeks and how they impact options price. Okay, so just briefly, let's talk about, we can see the volatility right here at the strike price is 62.24, I think. If I remember right. Let's check. Yeah, 62.24%. The delta is 0.40. The gamma is 0.29. You get the right. Delta 0.40. The delta here is 0.29. The theta is a negative 0.01, and the vega is a 0.01. Okay, this is the ask price of the option, not of the stock. They're asking 55 cents. This is a weekend, so the bid-ask prices has this huge spread. Today, I think, is Saturday night, so on Monday this will probably tighten up, I think. And that's the bid, so the ask bid. Let's just briefly talk about intrinsic value. That's this column right here. So what is intrinsic value? Well, for the calls, since this is the call side, right? These are puts over here, and over here we're looking at the calls. 750 strike price for the calls. Okay. So why is the intrinsic value here 0? Because the price of the stock is less, $7.19 is less than the strike price, $7.50. Okay. So if we were to subtract one from the other, we'd get 31 cents. So on the call side, you never see negative intrinsic value, but if you did, you'd see a negative 31 cents over here. But it always stops at 0. Okay. As a matter of fact, look way over here on the puts. See, there's the 31 cents right there, intrinsic value. Okay, so that's it right there. But back over on the call side, if this price was, let's say, $7.55, right, instead of $7.19, the intrinsic value would be 5 cents. Because 755 minus 750 strike price will give us 5 cents. Okay, that's your intrinsic value. The difference between the strike price and the price of this actual underlying product or symbol. In this case, we're dealing with a stock, but it could apply to futures as well, and commodities and other types of things that have options. Yeah. Okay, let's talk about extrinsic value. Well, extrinsic value is more complicated. We're going to get into that just now. All of the Greeks here impact extrinsic value, and even date, but we're going to get into that now. Okay, let's switch over to a spreadsheet, and we're going to demystify the Greeks right now. All right, here we are in a spreadsheet. It's basically the same thing. They're very similar. I added a few extra things here. Let's talk about what we got in front of us here. So here's the symbol again. This is the BRY symbol. I have a start date with this would be this Monday coming up because I'm doing this on Saturday. I think it's the 17th or 18th. So Monday will be the 20th. And then I just have an end date there for Tuesday. You can see the same price. I have a change here, $1. And we'll talk about this in a little bit. This net price here is the difference between, is really just the price plus the change. 819, right? Simple stuff. Here's the implied volatility that we saw, 62.14. And I'll talk about this right here in a little bit. Okay, here's the delta we saw there on the TOS platform that we just looked at, the gamma, the theta, and the vega. And here's the ask price. And here's that strike price. Okay, you'll see I got a section here. Okay, so let's dive into and demystify this whole thing. Let's talk about delta. Delta is for every 1 point that the underlying symbol, in this case, this stock BRY, for every point, in this case, point is a terminology used in trading futures. So for stock, which 1 point would mean $1. So for every $1 this stock moves, the delta is telling us that the price of the option, now not the stock, but the price of the option, which is right here, would move by 40 cents. That's what delta means. Now this is, all the Greeks are theoretical. That doesn't mean it's actually 100% going to happen, but these are good guidelines to go by, at least something to start with, okay? So that's delta. Again, delta is just simply saying that the price of the option is going to move by 40 cents for every $1 change in the price of the stock. All right? So let's do it. Let's do delta first. Is it true? Here's delta. I have delta right here. And here's the we'll call this the new, this column is the new option price, right? So let's just deal with delta right here, this one. Now you can see that I put a change, let's say from Monday the 20th to Tuesday the 21st. Let's say the stock changed $1 positive. It went from $7.19 up to $8.19. The delta says that the price of this option over here should change by 40 cents. There it is, 95 cents. Okay. Let's say that the price of the stock only went up 25 cents. Let's see what happens to the delta. I mean, not to the delta, sorry, to the price of the options. It only goes up to 65 cents instead of 95. So it went from 55 to 65 because the change was only 25 cents, not a whole dollar. Okay, so remember, delta is telling us how much the price of the options will change for every $1 this price moves. Since it moved less than the dollar, we could expect the option price to move less than 40 cents, right? It will only move 1/4 of this. So what's 1/4 of 40? Well, it's 10 cents. Is it true? 55 plus 10? Yep, equals 65. The math is right. The spreadsheet's correct, okay? Remember, you can always stop this video, pause it, go back and listen to what I'm saying about the Greeks if you need some time to understand it. All right, let's move on to gamma. This is the next one. Here's the gamma. What is gamma? Okay. Gamma is a little bit trickier, but stick with me and I'll explain it to you. Gamma says for every $1 that this stock price moves, let me put this back to $1 right here. For every $1 this stock price moves, we know that delta would move 40, the delta is 40 cents, and we talked about that. But this gamma says if this moves $1, then delta itself is going to change by 29 cents. So 40 would become, in this case, 0.69. Okay, so if the price of the stock, let's just say from this Monday to Tuesday here, these one day to the next, if it went from 7.19 to 8.19, gamma says that delta should go up by 29 cents. Let's put it to the test and see if is the spreadsheet right. Did I get my math right over here for gamma? Let me clear the screen. Okay, well, we have a $1 change. It says that delta should go up by 40, so that would be 69, right? Okay. And we should add the 69 to this price. In theory, that's what the price would be once it got to 819. So what we're talking about is, what would the option ask price be when this stock got up to 819, right? 719 plus a buck equals 819. Gamma says add 29 cents to the delta, okay, which simply just means we get 69 cents, and we add that to that price. Okay, so what is 59 and 69? Well, it's 124, right? 70 and 50 is 120 plus 14. I'm sorry, it would be not 120. 70 and 50, yeah, is 120. I'm sorry. Plus the 4, right? Let's check it. It is 55 plus 69. Really what it says it is. Yep, buck 24. Okay, so the math is right. Okay, so go back if you have to pause and understand gamma. Gamma is telling us the rate of change that's going to happen to delta for every $1 the price of stock goes up. That's probably the most complicated one for people to understand, because gamma is really a derivative. Okay, so we're talking about the rate of change. So for those that are familiar with, let's say, trigonometry, particularly calculus, is this, one of the central themes to calculus is the rate of change. So if you're familiar with calculus, this is very similar to that, the rate of change. This is the rate of change to delta for every $1 the price goes up. When the price of the stock gets up to 819, we can effectively add 69 cents to that price and get us our new options price. Okay, so that's gamma. Again, you can always pause the video and go back and listen to it again. Okay, why are the Greeks important? Because you can forecast ahead of time where you think your options strategy is going. Should I get out because things are going in the wrong direction? Understanding the Greeks can really help you plan ahead. Also help you plan whether you should even take the trade in the first place, or what type of strategy you're going to take if you do choose to get into an options trade. Okay, let's talk about theta. What is theta? Theta is one of the easiest ones to understand. It basically relates to the price of the option, how it's impacted by time decay. All right, so we can see this is just one day, right? From March 20th to March 21st is just one day. So for every day that passes, theta is saying this option price is going to be reduced by 1 cent. So from Monday to Tuesday, it would go from 55 cents to 54. Okay, and there it is right there, right? One day. Let's change it. Let's change this to say 2 days. What's going to happen if I change this to 2 days instead of 1? We can see theta change, right? Now it's 53 cents. I'm sorry, theta didn't change, but the price of the option changed based on the theta. Because 2 days, 2 cents. Right, but this could be 3 cents, 5 cents, 10, 12, whatever it is, depending on the underlying symbol. Yeah. So that's really useful. You could, if for those that want the spreadsheet, just let me know and I'll make it available to the members. Okay, let's just put it way out there. Like, let's say you wanted to know, I don't remember when this option expires, probably somewhere around the 17th of April. Right there would be your new options price. Of course, we know that when it gets down to the last day, really, it would be 0, right? The options price is basically going to be down to 0. But this is just theoretical. What would happen over time is theta would start going up. It wouldn't be 0.1 anymore. It'd be like whatever it is, 9, maybe 20 cents, whatever. Who knows? It would start to change. Okay, let's talk about Vega. So theta is the easiest one to understand, right? It's just how much the price of the option is going to change every day, how much it's going to decay, and time decay is going to affect the price. Vega is the hardest one to understand. Delta isn't too hard, right? Let's talk about Vega. Vega is a little bit more complex, really. It's Vega. Just remember, Vega, V for Vega stands for volatility. And you see I have it right here. So let me first define what Vega is. For every 1%, and here's where this comes in. For every 1%, this is percentage, 62.24%. You notice I put down below at 61.24. For every 1% change in volatility, okay, this is the sensitivity of the rate of change in volatility that will impact the option price. All right. So we can tell, since this is 0.1, this is 1 penny or 1 cent, it's not going to have a whole lot of impact on the price at the moment. So here I have a change from one. I don't have this. Let's just put this date back over here too. Okay, I'm having, this thing is, okay, now I think I got it. I'm gonna have to change it manually. Hold on a second. Okay. Since this is just one day, let's just say from one day to the next, keep this simple. From Monday to Tuesday, let's say the implied volatility for this particular stock, this symbol went down by 1%. Then Vegas is going to tell us that the price of the option is going to move by 1%. By 1 cent. So every 1% change in volatility, implied volatility, we apply the Vega to the price of the option or the premium. Okay, so you can see right here, Vega went from 55 cents down to 54. Because here was a 1% change between the two, right? And we only use one penny for every percentage change. Okay, let's change this. Let's say the implied volatility just absolutely took off, because the option price can go up or down depending on implied volatility. Let's say that the volatility spiked and went up to 80%. Now watch Vega right over here. Let me just do this. Watch the Vega price here. Not the Vega price. Watch the option price based on the Vega change, based on the implied volatility change. Boom. Okay, just get it out of the way. So there's your new option price. It wouldn't be 72.76. Obviously, this is a mathematical calculation, but it'd be somewhere between probably 70 and 75 cents for the option price. So the option price would have changed from 55 to probably 70 or 75 cents. Okay, so that just goes to show you how, in this case, implied volatility and how Vega impacts the price of the stock, the price of the option. Okay, since this is really small change, the option price didn't change too much. This is a pretty nice option change, though. Okay, I'd take it if I was long on this call. But let's just say this was higher, like 4 cents. Wow, look at that. Now you can see this approximately 18% change in implied volatility really motivated the option price to spike way up to $1.25, probably is what it would be. All right, everybody, it makes sense? Right, so if you're not sure, again, you can just go back and pause the video. If you want the spreadsheet, let me know. Let's just do this. Let's do this minus that. There's our percentage change. It's 17.76%. Okay, so now you just multiply this times that to get your price. Okay, now we gotta remember this is in percentage, so this gets a little tricky. So we're gonna multiply this by, let's see what happens. I think I might have to multiply by 100, but let's try it first this way. So we have to multiply that by 100. So let's do that first because we're talking about percentage. There you go. There's your 71 cents. That's the difference. As in volume, I just have it built into this equation over here, right? You don't see that part. But as implied volatility went up, and we have Vega here at 4 cents, this would be the actual price change, in this case positive price change to the option. Okay, let's do the math. Is it true? Is 71 cents plus the 55 cents $1.26? There it is. Bingo. These two match, right? So we know the equation over here for this is working properly. Okay. Yeah, we can delete that. That's fine. Thank you very much. So, very nifty, right? I hope the spreadsheet kind of helps you understand, and demystify all the Greeks, right? Or at least the Greeks that most. There's more to this than just the delta, gamma, theta, and vega. But these are the ones you really want to be paying attention to. Okay. So I hope you really enjoyed that. If you want to join the membership that I have, right below this video is a link to the Discord server. Just join that, and you can just comment in the general channel, how do I join? The membership is super cheap, $7.99 per month, guys. Not $79, not $799, just $7.99 a month. Okay. So jump on the Discord server, and you get nightly emails of my opinion about the S&P 500. There's a whole long symbol list I put out every night for all the members, all symbols that I have with my algorithm that picks the symbols that the members get to look at. And that's for futures. Okay, that's also for just regular stock. Also, optionable stocks are on the list. Okay, there's also there's sectors and industries are going to be in there too. So these are like these are about 4 or 5 different lists that go on the Discord server in a premium symbols channel, and the members get access to that every day. Okay, and there's a lot more to that. Obviously, you can join and get on the Discord server. You can communicate with and talk with other members. I'm on there most days. Okay, so $7.99. Come on over and join the Discord server and take advantage of the service. Okay, hope you enjoyed the video. Talk to you all real soon again next time.